Everybody. My name is Tom Capio. I work for Agidence, and as Fernando already mentioned, Agidence is a fairly new name. We're an automation systems integrator, but we were previously better known as Edgeman Automation. But recently there was a split up of the company, and so we went on with a new name. If you want to know more about my background, you can find me on LinkedIn. I think I should not go into much detail here for this seminar because we have plenty of material to go through. And I think the subject is much more interesting than my personal resume. So I invite you, please feel free to take a look and link with me via LinkedIn. Okay, renewable energy. I think most of us are aware of renewable energy and the reasons why it is important that people invest in renewable energy. But compared to the solar panels that we see on many residential homes, when you talk about industrial context, there tend to be much more options available, but it's also a more complex matter to regard and to make sure that you make the proper choices in light of the energy uses that you have within the industry. Now, sorry, going a little bit too fast here. One of the first reasons why companies invest in renewable energy have to do with legislation. As you probably know, there is a European Renewable Energy Directive, which requires the EU to attain 20% of renewable energy by 2020. And this European directive is then transposed into national legislation. And for each country in the European Union, there are different targets to be achieved when it comes to renewable energy. So there's a legal component that comes from national law that often companies within the European Union may have to deal with. Next to the legislation part, there's also a reason for investing in renewables out of corporate vision, for instance. A lot of companies these days, especially multinationals, are looking at the risks to the company related to global warming. And they may realize very much so that they have their part of work to do to help prevent global warming, because global warming itself is a significant risk to their activities and the economy and so on. So there's a risk management issue, but there's also opportunities for innovation, for competitiveness, why corporate companies look at renewable energy. There's also an image aspect. Companies want to be perceived as green, as sustainable companies rather than polluting ones. And more we see also that stakeholders, shareholders, but also the neighborhoods and so on, many stakeholders are putting pressure on companies to invest in renewable energy to become more sustainable and so on. And of course, companies wouldn't be companies if they didn't focus also on profit. And obviously, in many cases, investing in renewable energy is a way to reduce costs for energy and even to generate income via export tariffs, via feed-in tariffs, green energy certificates, and so on. So there are plenty of reasons why companies would look at renewable energy. If you look at the overall energy consumption in industry, then we're basically talking about two forms of energy. There's either electrical energy or there's heat. And those two combined represent about 1/3 of all global energy consumption and about 40% of global CO2 emissions. That is when we're talking about direct industrial energy consumption. Obviously, there's also a lot of indirect consumption, for instance, from transportation of raw materials to a factory or transportation of finished goods away from the factory to the customers. Other things are like water use, for instance, require also a lot of energy. But right now, we're just talking about direct energy consumption on site of these corporations themselves. Now, most of you will probably have heard of the Trias Energetica, which is the concept that you need to set the right priorities. And the first thing to do, if you want to make a difference, is to reduce energy demand in itself. And that means identifying where energy is consumed and identifying waste. You can see one of the pictures here This is an example of energy waste where you have clearly steam coming out of a leak in a pipe, and that's energy that's going to waste. So the first step always to do is to question yourself and ask, why are we consuming energy? Where are we consuming it? How much? And so on. And if we find waste of energy, to try and eliminate it. Another way to reduce energy demand is to optimize the processes, to optimize the settings, for instance, the pressure of a compressed air network, or to reduce the temperature of hot water, things like that. The second step in the Trias Energetica is to increase the energy efficiency of installations which are still using non-renewable energy. So you've eliminated waste. There's still some energy consumption left. How can you still improve on that? By, for instance, using more energy efficient electrical motors, or to have certain other components replaced that have aged and for which there are new, more energy efficient technologies available. And then the third step of the Trias Energetica has to do with renewable energy itself, and that means to maximize the use of renewable energy. So you've eliminated waste, you've made whatever consumption is left as energy efficient as possible, and then the goal is to use as much renewable energy as possible to cover that remaining consumption. And that's the point what this seminar is all about. If we look at the types of renewable energy, we see that there are many different forms of renewable energy. There is biomass, which can be used for heating, and through that heat you can also start to produce electricity. Sometimes it is turned into biofuel, which can then be used for transportation. There is solar energy. That's probably one of the most well-known ones. Obviously, the solar photovoltaic panels that everybody puts on their house these days. There's solar thermal, where you use the heat of the sun to heat water or other liquids. There's concentrated solar, which also can be used for heating or for using electricity, or producing electricity rather. And there's daylighting. One could say that is not in itself renewable energy, but I would tend to think that it is, since it avoids the use of electricity if you can just use the light of the sun to bring clarity into a building. Other technologies include wind, both onshore and offshore. Those are the big windmills. Wind turbines, but also, of course, there are sometimes micro wind installations, which are the much smaller ones that you sometimes see on top of the buildings. Water is obviously a very important one. It is the most used renewable energy source in the world, covering, I believe it's about 16% of global energy production comes from hydro. From the big dams, which we'll take a look at in a second. But there's also wave energy. There's water can be used as a source for cooling or heating. And then the last one that we have in this square is geothermal energy, where we take heat out of the ground to create process heat or even electricity. And then I also put on the right a overview of energy recuperation technologies, because in a way, any time that you take waste and turn it into a new form of energy, that is should also be considered a form of renewable energy, even if the original energy was not produced by renewables. If you turn waste into energy, then I consider that some form of renewable energy. Now the question, of course, is which of all these technologies is right for your company? Well, the first thing that you need to do is to really understand your energy needs. And one of the ways to do that is to create a clear map of all your energy flows. The image on the right here is a Sankey diagram, which basically takes the input of the energy and starts to divide it across all different processes and installations. And you normally do that typically for both electricity and for heat. And by doing that, you get an understanding of where energy is wasted and which are the most important energy consumers. And obviously, you always want to focus on the big consumers, because that's probably, if you make a difference, if you can optimize the consumption, you'll make the biggest difference by focusing on those big ones first. Once you have the vision or the proportional demand of all these different consumers, you can then look at the various process parameters and the constraints, and look at the temperatures. What temperature do we need? Do we really need, rather, compared to what it is set at? A lot of times what we see when we do energy audits for companies is that these are installations that have been there for many years, that were once set up at a certain temperature or a certain pressure, and it worked. And after that, people didn't want to touch the settings anymore because they were happy that everything was working. But obviously things change in a production environment, and sometimes things could have been reevaluated and settings might have been able to be updated, but it didn't happen because people were happy that it was running properly. And so it's very important that from time to time that you reevaluate your consumption and your settings, and to question whether or not things can be optimized, whether pressures can be lowered, whether temperatures can be lowered, flow rates can be optimized, and so on. Also, timing, for instance. When do we need certain processes? When do we need the lights to be on? Perhaps you were used to be running in 3 shifts and the lights were on 24/7, and now you're running only 2 shifts, but the lights are still on 24/7. So these are the things where you need to look at, and you identify waste and you optimize the potential. One of the important techniques to do this when it comes to heat is a pinch analysis, where you really go structurally analyze all the different energy demands as well as the available temperatures from waste, and where you really go and look for cooling and heating profiles, and you try to match everything, and you try to recover as much of the waste energy as possible to power or to use for processes. Now, but pinch analysis, I won't go into it much further because that becomes a very technical subject. So it's something, if you're interested in, I would suggest you look that up separately. Good. Once you have an idea of the profile and where the opportunities lie, then you need to consider which renewable energy technology might best fit your profile and your needs. And that means you need to prioritize your goals and expectations. And in many cases, that means, first of all, looking at the financials, because obviously most of the companies, again, are looking at profit, are looking at investments that make sense, that actually deliver on their promises. So the first you need to look at is what type of return on investment does my company expect for an investment? Are there limits on the paybacks? What we see that in many cases companies are still focusing on payback terms of 2 years or less, and that is sometimes not very easy to achieve when it comes to investments in renewable energy. When you go and calculate these things, you need to think about potential subsidies or grants that you may get from the government for producing renewable energy. You need to look at the income from the green power certificates, for instance. You may need to look at available budget, because maybe you are in competition with other projects that are necessary for maintenance reasons or whatever. So obviously financial parts are the first thing to take a look at. Another one is environmental issues. In many cases, solar panels, for instance, are not that difficult to mount. You put them on the roof, nobody has really much personal impact from it. But things get very different once you start talking about, for instance, wind turbines. If you put a big wind turbine on your site, you need to think about permits, building permits, but in many places there are limits to how close residential homes may be to wind turbines because of the effect of shadow and things like that. There may be noise requirements. If you're burning biomass, you may need to think about those emissions as well. So there's important environmental aspects to take into consideration. And then another part is the corporate image. Depending on what type of priorities the company has, it may prefer to invest in one versus another technology. We know that, for instance, currently in Belgium, there's a lot of discussion about biomass being used in old coal power plants, where on the one hand it's said to be renewable, but the technologies that are being used are not necessarily the most efficient ones. And so there is a lot of discussion going on about renewables in certain forms, and you need to be aware of that, because making the wrong choice may impact the image that the company has among the stakeholders and the outside world. Other things to think about when we're looking at renewable options deal with, like I said, the corporate priorities, but also the energetic performance. Not all technologies deliver on the same efficiencies. There may be technical feasibilities where something may look good on paper, but may be very difficult to implement within your own organization because of technical requirements and so on. Very important also to consider is what happens when you invest in renewable energy. What happens to your contract with your energy supplier? In some cases, we know that the energy supplier is not always happy that they have to take on a customer who produces energy themselves, because obviously they lose some income, and to some degree it may make it more difficult for them to safeguard their balance on the net. If you don't consume everything you produce yourself, you will be injecting energy into the electricity net, for instance, and that may make it harder for the energy supplier or the distribution company to balance that. And they will, for sure, take that into account when they calculate the tariffs that they charge you for energy. Other things to consider are building permits and things like that, like I mentioned before. And the question, do you really want to produce yourself, or is it sometimes an option that instead of producing renewable energy yourself, that you just purchase renewable energy, that you find a green energy contract from a supplier, which gives you the right to claim that you produced with renewable energy without having had to make the investment yourself. So these are some of the considerations. And if we base on that, we go back to the overview that I presented earlier, and I have taken out some of the options for the simple reason that they tend to be not very realistic on a company specific basis. The biomass to biofuel, well, biofuel like ethanol or things like that tend to be used in transport, usually not going to use them much in a production side. So we took this one out. Offshore wind obviously is also not really applicable since I don't know too many production sites on the ocean. Marine power, same reason, obviously. And geothermal electricity, while it is a technology that is fully under investigation and going through pilot projects, it is not at this point a very common technology. So for now, geothermal is mainly focused on heating applications. Good. Now let's go into the specifics of producing electricity, renewable power, as we call it. The things to consider are the own production profile that you have at your company. It's important to understand what your peak demand is, what your off-peak is during the night and during the weekends, for instance, and what your baseload consumption is like. Because, like we mentioned before, producing energy yourself does have an impact on your contract. And so you really need to be able to understand what the potential of the technology is that you're investigating, and how much of the production capacity you will be using through self-consumption, and how much of it you will be injecting into the net. You have to take into account that production is usually intermittent, that you cannot count on full capacity 24 hours a day, 365 days a year. And you also need to think about the capacity that you would like to have versus the space requirements that you have available. A wind turbine in itself doesn't have much, doesn't have a very large footprint on the ground, but it does require quite important zoning aspects. Same with solar panels. If you don't have space on the roof, or you have a roof that cannot carry the weight of solar panels, this obviously significantly limits the potential that you have for solar panels at that point. And like I said before, you need to look at the energy contract and how producing locally will impact the energy price, how it will impact the grid connection costs, the transmission and distribution tariffs, and so on. You may need building permits, environmental permits, and you really do need to think about how much extra maintenance you will need to provide for these installations, because it's not just a matter of investing in an installation for renewable energy and just harvesting the energy and that's it. No, in many cases there is an important aspect of maintenance that will need to be taken into account, and which obviously reduces the gain that you have from renewable energy. So when we talk about renewable power, one source that we mentioned before was biomass. Now, if we talk about biomass, we're talking about hopefully self-generated waste streams or purchased biomass. With self-generated waste streams, I'm thinking, for instance, a brewery can have the grains, the spent grains, and the various products that they use to produce beer. At the end of the line, they have a product that used to be sold as animal feed. Well, perhaps it may turn out that it's a better financial model to use it as a biomass source for heating. Other examples are companies that make wood products and have a lot of shavings or sawdust and things like that, can turn that into pellets or briquettes to be used in an incinerator. So usually we're talking about industrial waste, co-products, food waste, agricultural residues, and so on. And when we're talking about producing electricity with this biomass, we usually go through an anaerobic digestion process through which biogas is produced, and that biogas is then usually combusted in a combined heating and power module or through a fuel cell. The advantages that you have with biomass for producing electricity is that in many cases it is a form of waste management, and so in a way you can reduce your waste management costs, and at the same time you can reduce your energy costs. In addition, you usually get, or at least in many countries, you will get green energy certificates, and the remaining material after digestion, the digested, can often still be sold as a product for as a fertilizer style product that can be used in agriculture and so on. The important thing to remember is that you need to make sure that you have practical use for the produced heat. If you cannot use the heat properly, then you will never get the full efficiency of the solution. You need to be able that you have sufficient availability of biomass, and that the quality of the biomass is also sufficiently good or stable enough to make sure that the whole energy production process remains on target. And you do need to think about the complexity of these type of installations because they do require a lot of maintenance. Another, the more common method of producing electricity is the photovoltaic solar power, where you have different types of solar panels. You have the monocrystalline panels, which have the highest efficiency rates, up to 21%. They have the longest life. They perform also better at low light conditions and in warm climates, but they're obviously the most expensive panels, and they do have an impact if they get dirty or they're under shadow. You do see a significant drop in production. The cheaper panels are the polycrystalline panels, which are simpler in production, but they do also have lower efficiency and lower heat tolerance. And then finally, there's the flexible film, the so-called thin film solar cells, which are fairly cheap, and they do offer some important advantages in that they're flexible and they can be glued to a surface that is not straight. They look more homogeneous. They have fairly good heat and shadow tolerance, but the efficiencies are quite low, and so you need a lot more space to use this for the same capacity than you do with monocrystalline panels. Important to know also that with PV panels that these can be, usually they will be roof mounted, but there are ways to integrate them into buildings as well. The advantage is that all these types of panels and film, these are common, affordable, reliable technology with limited maintenance requirements. They offer a certain level of visibility, which may be good for the corporate image. But of course, there's intermittent production, and there's a significant impact based on where you're located. Obviously, the south of Spain will get a whole lot more sun per year than the northern part of Ireland, for instance. There are solutions to provide more electricity by putting panels on a tracker, which tracks the sun. But you need these panels then by themselves produce up to 30 to 40% more electricity. However, you need more space because they need to be farther apart, and also the maintenance and investment costs are much higher. The next one is wind power. These big guys are popping up everywhere. Your horizontal axis wind turbines have now reached a technology where offshore they are going up to 8 megawatts in capacity, which is quite amazing. These are the latest prototypes. Onshore, the current range is in the 2.5 to 3 megawatts. So those are also already quite impressive numbers. These days, I think we can easily claim that this is common technology, high capacity, but while there is a sustainability image, there's also a lot of opposition to it. People tend to say, not in my backyard. They're all in favor of renewable energy, just they don't want these wind turbines too close to them. They don't want to be disturbed by the shadow and so on. Important to realize is that these require significant investment and maintenance budgets, and there's quite a lot of challenges from a zoning requirement and so on. Next to the horizontal wind axis, there are also vertical axis windmills, which tend to be smaller in capacity, although the largest one currently is in the 4 megawatt range, which is quite big as well. One advantage of the vertical axis windmills is that they can take advantage of sudden gusts and peak wind, because they don't need to turn into the wind first. They take the wind from all sides. But we tend to see these solutions more for small wind, micro. So basically, yeah, I think this slide you can take a look at yourself. Wind power, it's an important one, but obviously it's intermittent again, and there's some problems sometimes to get these things installed. As mentioned before, the most important form of renewable power comes from hydroelectric power. The picture on the right is from the largest dam in the world in China, the Three Gorges Dam. That type of technology currently covers, I think it was about 16% of global electricity produced, so it's just really important. It does, of course, have both environmental and social impact. I think we've all heard stories of people or entire towns in China that had to move to build new dams and so on. There's an impact on fish, on dry land, obviously, as well. And what we see is that there's not much development done for small capacity or low head applications so far. There's also an impact of availability of water and drought, things that may become more important as global warming continues. The big advantage of these hydroelectric systems is that they can both provide peak load and base load and storage, and they can react fairly quickly to changes in demand. So these are quite flexible systems. Now let's get to the renewable heating part of the presentation. Again, important to consider for these investments is your consumption profile. You need to have a very clear understanding of what temperatures you need, in what volumes, and the timing of those needs. If we look at industrial heat demand in Europe, there's been studies done, and basically you can divide the needs up in three levels of heat, going from low temperature heating, which we then define more or less as up to 100 degrees. That's good for about 30% of heat demand in Europe. Usually this type of heating is used for space heating, for washing, rinsing, food preparation, etc. Medium temperature is between 100 and 400 degrees centigrade, which is good for about 27% of demand. That type of heat is usually used for evaporation, drying steam as a heat carrier, and so on. And then there's high temperature applications, which is above 400 degrees, good for about 43% of demand, and we see that mostly in the manufacturing of metals, ceramics, glass, etc. Heat production can be done via flue gases and via electric induction, among others. So now if we want to look at the renewable heating solutions, clearly one of the first one is biomass heating, where again we have these self-generated waste streams or purchased biomass, like we had for the power before, but where instead of for power we go through a digestion process to create biogas. Here we usually see direct combustion. The advantage again is that it is a way to reduce waste management costs and energy costs. And it offers high temperature applications. The picture on the right is a combustion chamber for big bales of hay. So it's a fairly much simpler process than a digester, for instance. Having said that, while it is a simpler application and easy to understand, it doesn't mean that it is free of maintenance. These are, again, the installations themselves do require quite a bit of maintenance, and emission controls are also quite stringent on these systems. Solar thermal heating, there are various technologies for that, starting with the traditional collectors that we see on residential roofs sometimes as well, the flat plates. These are usually well suited for low temperature applications. It's a common and reliable technology, but obviously, depending on the location, geographical location of your site, you may or may not get a lot of production out of it on a yearly basis. One step up is the evacuated tubes, which can reach higher temperatures. So we're talking about low to medium temperature applications. And they are also able to heat larger amounts of water in shorter time. They are more complex in construction and therefore are more expensive in cost as well. And then the next step up from there is concentrated solar, or concentrating solar, really focused on medium temperature applications. Important there is that you will tend to need storage, which again requires space requirements. It's higher investment, and yeah, the largest systems here tend to be used also for power generation, where you basically have hundreds and hundreds of meters of mirrors all concentrating onto one focal point where steam is produced and power is produced. Geothermal heating, there we have also different levels. We have shallow geothermal, which is usually what is used for domestic use for residential homes. These can be horizontal tubes or vertical tubes up to 150 meters deep. Usually you can get about 10 to 14 degrees centigrade out of the ground temperature. And through the use of a heat pump, you can then pump this temperature up to a higher level, for instance, to be used in a home for floor heating or so on. Once we go deeper than that, we can go to deep geothermal applications, which is really what industrial and utility scale projects are like. It's been shown that at a depth of 2,400 meters, you're reaching about 90 degrees, which is ideal for heat applications. But there are now several pilots running where they're want to go even deeper than that. And estimations are that at a depth of 10,000 meters, for instance, that the temperature is reaching 374 degrees centigrade, which obviously gives you temperatures that allow direct power production through steam that comes up from the ground. And the idea there is that over time, people could use steg-based gas turbines, but instead of using gas, they just use the steam from deep geothermy. Other applications for geothermal is cold and heat storage, where in summer you use the temperature from the ground for cooling, and in summertime you use it for bringing up heating. The efficiency levels can go quite high. If you're using an aquifer thermal energy storage, you can reach a COP of up to 20, which is quite amazing. The main advantage of geothermal is year-round availability. However, you do need to take into account that these require significant investments. And so this is an overview. I invite you to take a look at this in the PDF. It will be a little bit more clear, but it shows you how the distribution of the working temperatures versus the applications, going from space heating up to, around 100 degrees centigrade, whereas for chemical applications, high temperature processes, it's from 100 to well over 200 degrees. And then based on these different applications, you can then see which specific technologies fit the temperature range that you're looking for. So I invite you to take a look at that in the PDF file that you will get later on. I see from timing that I need to hurry up a little bit. I mentioned daylighting also in the renewable energy, because basically using daylight is simply avoiding the consumption of electricity for burning the TL lighting or LED lighting, or worst case incandescent lighting. The advantage with daylight obviously is that you have lower cost, you have usually a good light color and color quality. Problems with daylighting is sometimes that if it's through a window or a clear canopy, that you get a strong contrast between the light beam and the shadow, and obviously there's an intermittency and a seasonal impact. Technologies you have to think about, if you're talking just regular windows, you need to make sure that you don't overheat the space in summertime. But there are solutions to capture light and transmit it on a more efficient way, like the light catcher that you see on the right. And of course, you want to outfit your artificial light indoors with light sensors and the possibility of dimming in function of the available daylight that comes into the building. And then another thing I wanted to mention was energy recuperation, because as mentioned before, there are a lot of forms of wasted energy. Flue gases, when you have processes that burn certain products or ovens that are heated. A lot of times you have flue gas at temperatures that are very much still useful for other applications, especially low to medium temperature applications. A lot of energy is available in flue gas. Similar for wastewater. Low temperature applications are very common. Electric motors that are running all the time create a lot of heat. There too, you can recover the heat. For instance, the compressors for compressed air network, ideally suited for low temperature energy recuperation. The combined heating and power electricity production obviously doesn't make sense if you do not recuperate the heat. And other applications may still be possible. Then when you're talking about kinetic energy, we're talking about braking energy. For instance, in automated warehouses, you have stacker cranes that can easily be converted to recuperate the braking energy. And instead of converting that energy into heat, they now can create new electricity and either store it through a supercap or inject it into the net. In addition, you have the advantage that you can do some peak shaving, and you can also reduce the wear and tear on your insulation. Some conclusions. When we see trends in renewable energy, we see that renewable energy is expanding at an ever faster rate than before. In 2014, nearly half of all global net new capacity worldwide was renewable. And actually the latest news that I saw was that in 2015, we actually did see that more money was invested in, or more new capacity was added through renewables than through fossil fuels, which was good news. The expectation is that by 2020, about 2/3 of new capacity will come from renewable energy. And if we look at the price or the cost forecast, when we see that onshore wind power has dropped on average 30% in the period 2010 to 2015, and is expected to drop another 10% by 2020. And for utility scale photovoltaic, we've seen a drop of 66% over the past 5 years, and another 25% is expected for the next 5. While barriers to renewable energy, obviously, oil prices are currently extremely low, abnormally low, and that means that the return on investment calculations, the payback calculations, are less favorable for renewable energy. We also see that the carbon markets are still not very effective. There's still overcapacity in power generation from nuclear, coal, and gas, and so these are all putting pressure on the economic numbers behind renewable energy. Nevertheless, even with scaling back of tax incentives and grants and feed-in tariffs, we're very much believe in the power of renewable energy and in the need for renewable energy. And I think it's clear that a lot of jobs can be created from there. And I look forward to getting some questions from you all. I hope it was clear, everything I presented. You have some source material here as well, and I invite your questions at this point.